So section 8.4 should just be a review assignment. I'm going to go through this kind of quickly, but feel free to pause it, go back and review anything you're struggling more with. We need to understand the slope of a line. We can have a positive slope, and we read lines like we read a book from left to right. So a positive slope going left to right is going uphill. Mathematically, we have a positive change in the y over a positive change in the x. And so that little triangle stands for change in. That's a delta symbol. We use that in math. So it's a positive change in y and a positive change in x. Versus a negative slope, right? If I go from left to right, I'm going downhill. I struggle with that, so apparently he's falling. I don't know, that's kind of disturbing. But what do we have here? Well, if I go left to right, we have a negative change in y over a positive change in x. If we have an undefined slope, I'm not there yet. If we have a slope of 0, then we have a flat line. That makes sense logically, that you would have a flat slope would be a slope of 0. What is the change in y this time? Well, the y value doesn't change. So the change in y is 0, and the change in x is basically any number. I could go left or right, any number. So it'll be any number. And why does this make sense again algebraically? Well, since slope is rise over run, the change in y over the change in x, if I do 0 divided by any number, that will be a slope of 0. The last one we call an undefined slope. That should sort of make sense. If I'm walking up, right, a flat wall, then we want to call an exorcist. That's undefined. It doesn't work that way. We don't walk up vertical lines. So what do we call this? Well, we call it an undefined slope because this time the change in y is up and down any number, and the change in x is 0. And any number divided by 0, we call that undefined. We've done that in prior chapters. Okay? So, here's an example of a little more algebraically. Yes, we know slope as rise over run. Rise is the change up and down. Run is the change left and right. We could just write that as change in y over change in x, or delta y over delta x. But algebraically, how do I get the change in the y values? I subtract them. To get the change between two numbers, I subtract them. So I subtract the y values to get the change in y. I subtract the x values to get the change in x. So this is not a formula we should have to memorize. That is something that should make sense. That here's an example where I have 2 points, 2, 3. So that's 2 up 3, and 6, 3, 4, 5, 6, and down 1. And we would like to find the slope between these lines. I can do this algebraically. I can do the change in the y values. What are the y values here? Well, that would be the 3 and the negative 1. So the change in those would be the second one, negative 1, minus the first one. So negative 1 minus 3 would be negative 4. Over the change in x would be, well, here's my second x value, 6, minus the first one, 2, gives me 4. So negative 4 over 4, or negative 1. This should make sense based on our picture because I can see that the slope is going negative. We also said that between these 2 points, the y value went down 4, and the x value went over 4. And so that is our change in y, that is our change in x. So negative 4 over positive 4, negative 1. Now sometimes people will switch and they'll do 3 minus negative 1 and 2 minus 6. That wouldn't matter. What you're doing is you're starting at the points and going up 4 and then back 4 here. Well, what would that do to the slope? Well, if you switched it, then you would have a positive 4 for the change in y, a negative 4 for the change in x, but still, a positive divided by a negative is a negative slope. Okay? So yeah, you should be able to find the slope between two lines. Visually, I encourage that a lot in Math 55, but we are going to be dealing with some bigger numbers, so you should be able to handle this formula, but this should be something that makes sense, this y2 minus y1 and x2 minus x1. You also must be able to graph. Ideally, from slope-intercept form. They call it slope-intercept form because it has two parts, the slope, and the b is the y-intercept. I wish they would call it slope-y-intercept form, but they just call it slope-intercept form because that b is not just any intercept, it is the y-intercept. Well, why does this matter? Well, the y-intercept is where x equals 0. If I put a 0 in the equation, I will get 0 comma b, 0 comma whatever y is. Literally, if I put a 0 right here, I would get y equals m times 0 plus b, y equals b. That is the y-intercept. That b at the end will always be the y-intercept, because when x is 0, that y will be whatever that number is at the end. Well, that's a point. So when I'm graphing 4x plus 1, I already know a point. I'm going to start with the y-intercept. So on this one, I'm going to start with the y-intercept. We have mx plus b. Well, our b here is a 1. So where will I plot that point? Well, people go, well, at 1. 1 where? 1 on the y or 1 on the x? Well, it's called the y-intercept, or it's the point when x is 0, y is 1. So that would be on the y-axis. How many points do I need to make a line? Generally, your teacher has you do 3 because, like me, you're probably sloppy, and so 3 make it straighter. But geometrically, 2 points make a line. We are already halfway there. We have a point. How do I get to another point? Well, we use the slope. See, we use the slope from that y-intercept. So we start at the y-intercept, 0, 1, and the second we use that m, which is 4, and this is the only time that I want that slope, I want that number to be a fraction, because slope is rise over run, change in y over change in x. This one's 4 over 1. What does that mean? Well, from this point, to get to the next point, we will rise 4, run 1. We will go 4 up and 1 to the right. From the y-intercept, go up 1, 2, 3, 4, and right 1, and plot a point. What if I wanted another point? I could go from there and go up another 1, 2, 3, 4, and write another one, and I could keep going. What if I wanted to go backwards? Because our slope is currently 4 over 1, which is 4 up 1 and 1 to the right. Well, I could go down 4. That just means I'd have to go left 1. Because going down and left, a negative divided by negative is still a positive slope. So I could go down 1, 2, 3, 4, and back 1. That should be plenty of points to draw a line. Let's practice this again. So in this next one, it is currently in y equals mx plus b form. It's currently in slope-intercept form. What is the m? Well, somebody's like, well, there's no number there. Yes, there is. That's a negative 1. So our m is negative 1. We want the slope as a fraction, so over 1. Our b, what is the number there? Negative 8. Which one do I start with? Start with the y-intercept, 0, comma, negative 8. So I go here and I go down. 1, 2, 3, 4, 5, 6, 7, 8. And I plot a point. From there, that we've used this, from there, we use the slope. I will go negative 1 over 1. 1 down, 1 to the right. Not from the origin, not up here. We're going to do it from the point we already have. So from that negative 8, we're going to go down 1 and right 1. Down 1 and right 1. Well, we're kind of running out of space as we go down here. This is where I would encourage you to know how to go backwards. Going down and right is the same thing as going up and left. If I go up 1 and left 1, up 1 and left 1, I end up with the same line. Why? because a negative divided by a positive is the same thing as a positive divided by a negative. Either way, they are a negative slope. Next one, y equals mx plus b, or m is a fraction. Don't freak out, that's actually a good deal. Not bad when it's a fraction. Or b, there is no number there. You're like, okay, so 1. No. It's plus what? Plus, there's nothing there, so b is 0. This would have a y-intercept when x is 0, y is 0. There's our b. So when I go to graph this, I start at the origin at 0, 0. And from there, we use the slope down 2, right 3, down 2, right 3. If I wanted another point, I'd go down another 2, right another 3, and I could plot another point. If I wanted to go backwards, I could go up 2 and left 3. What if it is not in slope-intercept form? Well, we need to be able to get it in slope-intercept form. We need to get that y by itself. So what do? Isolate that variable. Now I put this under here. This does not make 5 of anything. Those are not like terms. So we have negative 4y is equal to, I encouraged you guys to put the x first. You're like, well, why would we want to do that? Well, because it's going to help us get mx plus b. So even though x doesn't have to be first, it's going to help us when I get mx plus b. Our last step to divide by negative 4. What do we divide by negative 4? Each term gets divided by the negative 4. The division distributes just like multiplication would distribute. So now we have y is equal to negative divided by negative. How about positive 3/4 x minus 8 divided by 4 is 2. So we have a y-intercept of negative 2 and a slope of 3/4. So from there it goes up 1, 2, 3, and right 1, 2, 3, 4. And really those are the only 2 points I need to draw a line. How about this one? Well, it's similar. We're solving for y. It's not ready to graph. So what we're going to do is we are going to add the 2x over. Do not add those. Those are not like terms. So that y is equal to 2/3 x minus 1/3. Well, that is not cool. See, the issue here is that I have a fraction in there. Well, let's see what we can do. I could, and if this were a test question, and I wouldn't do this on a test, I could go down to negative 1 and go, well, negative 1/3 would be about right here. And from there, rise 1, 2, so I'm now at 1 2/3, and over 1, 2, 3. And I could sketch that, and I would get an overall line. I'm not loving this, though. See, this isn't really working out so well, so what do we need to do? Because if you're graphing this in your homework, they're not going to let you graph like the fractions like that. So what you're going to have to do is you're going to have to pick some points. Generally, 2 good points to start with would be the x-intercept or the y-intercept. Because this doesn't graph in a pretty point. But let's see what happens. Well, the x-intercept is where y equals 0, right? So I can take the original equation and I can basically put in a 0 for the y. So negative 2x equals negative 1, so x is equal to positive 1/2. So we have a point, 0, nope, x comma y. So how about 1/2 comma 0? That's still not a pretty point. But we could then go to 1/2, 0, and then go from there up 2 over 1, 2, 3. Still not going to help us much. We can do the y-intercept, which is where x is 0, but we already saw when x was 0, we got -1/3. So neither of those was really good points this time. So what you'd want to do is you want to pick a value of x that is going to basically clear out these fractions. So I have, let's just take what I have. Y is equal to 2/3 x minus 1/3. We already saw 0 doesn't work. What would a 1 do? Would 2/3 minus 1/3 be a whole number? No. Well, let's check. Well, what if x were 2? 2 times 2. Would 4/3 minus 1/3 be a whole number? Would 4/3 minus 1/3 be a whole number? Sure it would. That would give us 3/3 or 1. So now we actually have a nice point. We do have the point 2 comma 1. 2 comma 1. There's my nice whole number to start at. And then from there I could still use the slope up 2 over 1, 2, 3 and get to our next point. There might be a couple of these in the homework. I'm not going to test you on this, but I just want you to know that in real life things aren't always going to be pretty. So what do we do if I have to graph something like this? Well, this is where I would use technology. 2/3 x minus 1/3. Let's see. 2/3 x minus 1/3. Once again, not super pretty, but I can see that it goes to the point 2, 1, and then from there it goes up 2 over 3, up 2 over 3. So if I get to something more complicated, that's where I would have technology graph it, because this has a sucky y-intercept and a sucky x-intercept. So it's not going to be how we want to solve that one. Okay. Last but not least, you need to be able to graph the following things. Y equals -3. What does this look like? Well, this is a graph that crosses the y-axis at -3. Basically, y must equal -3, x can equal anything. See, no matter what x equals, y equals -3. X could equal 1, and y would equal -3. 1, -3. X could equal 2, and y would equal -3. 2, -3. X could equal -1, and y would equal X can equal anything as long as y stays at -3. What type of line am I getting down here as I'm filling in these points? Y equals -3 will always be a horizontal line. Why? Because x will equal anything, the graph will go left and right, but the y value is stuck. The graph cannot go up and down. The y value is stuck at -3. Y equals will always be a horizontal line at the y value. X equals 3, well, if y equals a number is a horizontal line, it makes sense that x equals would also be a vertical then. Well, let's see. X can equal 3, y can equal, see there is no y here, so y could equal anything. So we could have 3, 0. Go on the x-axis. We could have 3, 1. We could have 3, -1. See, as long as the x stays at 3, y can equal anything. What type of line are we getting this time? See, if y equals our horizontal, x equals our vertical. That's confusing because we're like, well, wait a second. Sorry about that. Like, wait a second. I'm looking at this going, the y-axis goes up and down, but y equals a number is left and right. I understand how that can seem confusing. But the idea is that the y value on y equals -3 must stay constant. Therefore, the graph can't go up and down. It only goes left and right. X equals is a vertical line. You're like, that's confusing because the x-axis is left and right. I get that. But if x must equal 3, then the graph cannot go left and right. It must only go up and down. Okay? So that is it for our first section. Like I said, it should be mostly review, so hopefully that's not terribly confusing, but feel free to see me, get some help in the Learning Center if you need any more help with that.